If you change your mind, let me know. I can stop recording. It's no big deal. All right. So we are still working on day one. All right. We have two learning targets. The one learning target, I can use a box and whisker plot and stem and leaf plots to display information. And again, we talked about the stem and leaf plots yesterday. That's in the video from yesterday. And we're going to be talking about box and whisker plots today. I think, no, we didn't talk about box and whisker plots in this class. And then on Thursday, we'll do linear regression. All right. Okay, so those were the learning targets. Hopefully, when you clicked on this, it said, you'll need to click edit, right? Hopefully, when you clicked on this Google form, because if you submitted anything from yesterday, your name should already be in there, right? So for me, I didn't save my stuff, so I'll have to put my name in. But for a lot of you who submitted your stuff yesterday, your learning target's already in. So we're just scrolling down. We did the warm-ups yesterday. We talked about graphs. Here's the video from yesterday's class. So if you missed yesterday's class, there's the video. We talked about example 1. We found the mode. We found the median. We talked about example 2. This was frequency tables and how to find the mean in frequency tables. This was example 3, stem and leaf plots. And okay, you'll have to help me out. Did we do example 4? I feel like we did example 4. Anyone want to confirm or deny?
I Mister, I don't know why, but none of my stuff saved in, yesterday.
Okay. Did it, when you clicked submit down here, when you click submit, did it say it's saved or what happened?
Oh, I didn't click submit.
Ooh, okay. Well, in that case, what I would advise is to, the whole video for the whole class is actually, right here. So if you don't, you don't even have to like answer the questions again. You can just go through the video and get that stuff. All right. Use that video to reclaim your answers. Then I would say you don't have to, just put it. You can just like use no, it's video, so you can just like skip ahead, right? You can just kind of like make it go on, go fast forward, and then right when you see the answers, you can just put them in. All right. So there we go on that one. Let's see. So at the bottom of all these, do I still do that? You know what? I think I failed to. All right. Well, usually at the bottom of these, I always say click submit, and I have a little video. I'll have to add those again. I thought we were past that, but that's all right. That's all right. So I read a little note. The note was we stopped at example 3, so we need to pick up on example 4. So my note says we need to start with example 4. All right, that's where I'm starting. Example 4, somewhere about midway through the form. All right, rod. We're going about rod. Rod from example 3. All right, let's remember what example 3 was about. Example 3 was this. Oh yeah, stem and leaf plots. Right. Rod is doing internet search on the number of gasoline price changes per year in gas stations in his county. All right. So what he's counting here is he's saying like, how many times did a gas station change the price of gasoline in a given amount of time? Does it say the amount of time? Per year, right? So it's how many times a gas station changes its prices. Some gas stations change their prices maybe only 11 or 12 or 13 times per year. And then there was a gas station over here at the other end of things that changed the prices 72 times per year. All right, so he's recording the data from this kind of thing. So he's going to take that data of all those price changes, right, of all those gasoline stations, and he's going to put it into another kind of graph, right? This kind of graph here is called a box and whisker plot, or sometimes just a box plot. This is the box of the box plot or box and whisker plot, right? This is the box, and these little things sticking out the sides, those are the whiskers. So if you can just kind of remember that, like a box and whisker plot has a box with a line through it, and then has 2 whiskers on either side. And here's how this works. This little whisker here, right, the whisker on the left, is going to be the minimum. That's going to represent your smallest number. The first part of the box is going to represent Q1, the first quartile of your data set. Q2 is going to represent your median. That's the little line that goes through the box. That's always going to be the median. All right, not the mean, but the median, the middle number. Q3 is the end of the box. That's how you know where the end of the box is quartile 3. And then there's a whisker, and then the whisker ends at the maximum. So you basically, to construct any, yes, Q1 is the edge of the first of the edge of the box. So to construct a box and whisker plot, you need what's called the 5-number summary, right? You need to be able to find 5 numbers that conform to your data set. You need the minimum as the smallest number. You need the Q1, the Q2, which is the median, the Q3, and the maximum. All right, you need 5 numbers in order to be able to construct this. And it's very important that this needs to be on a number line. You don't want to create just a random sized box and whisker plot. You want it to be on a number line, because the whole point of this graph is to kind of see how spread out. For instance, if this is on a number line, I can see the spread between the two ends of the whiskers, and I can know the range, right? If I wanted to, I can just see based on where if it's on a number line, I can see the quartile 3 and quartile 1, and I can get an idea of interquartile range, right? Q3 minus Q1, I can see how spread out it is. And of course, the bar in the middle gives me the median, which gives me an idea of the center of the data. They call these quartiles because 25% of your data is in each little section, right? There's 4 sections, so that 25% of my data is located between the minimum and quartile 1. 25% of my data is located between quartile 1 and the median. All right, another 25% of my data is between the median and quartile 3, and the last 25% is between quartile 3 and the maximum. Yep. So, all right, so let's see. The box and whisker plot shows all 4 quartiles and the least number. It should be drawn to scale, that's on a number line, so that it changes shape depending on the distribution. Recall that the interquartile range, the IQR, can be computed by subtracting Q1 from Q3. The box part of the diagram helps you find the interquartile range because it displays both Q1 and Q3. So if I wanted to find the interquartile range of this real fast, I could just say, okay, I see 55, I see 23, 55 minus 23 is 32. That's the interquartile range, right? The interquartile range of this box and whisker plot is 32. And that tells me, that interquartile range tells me that 50% of the data is between quartile 1 and quartile 3. So I know that half of the data of this data set is located between quartile 1 and quartile 3. So it gives me an idea of the center of the data and how spread out that center is. If the quartiles are really close together, if these quartiles are really close together, then that tells me my data is really concentrated in the middle, right? If 50% of my data, if 50% of my data is really close to the median, then that means my data is very kind of concentrated in the middle. If my box is really, really long, then that tells me that the middle of my data is fairly spread out. Okay, so by just looking at the size of the box compared to the whiskers, you can get an idea of the dispersion and center of the data. So the interquartile range is 32. That means that 50% of all the gas prices are within this range. Notice that we can also find the range using the box plot, maximum minus minimum, but we can't find the mean, right? The box plot has nothing to do with the average or the mean. It's always the median. You can use the statistics menu on your graphing calculator to find a box and whisker plot. I don't know if we're going to do that, but it can be done. Your graphing calculator can display you information in a box and whisker plot. So my kind of check to make sure you understand this is, based on the box and whisker plot from example 4, what percent of the gas stations had 55 or fewer price changes? So what percent of the gas stations had 55 or fewer price changes? I'll give you a little second to think about that. If you want to write it in the chat, I would appreciate your participation. Lets me know that there are live learners on the other end of these screens. Otherwise, I feel like I talk to a computer screen all day. What percentage of gas stations had 55 or fewer price changes throughout the year? All right, so nobody is hitting me up in the chat. Maybe I'm not sure what that what that means, but okay, that's all right. I'm asking the question. Trying to answer this question down here. Based on the box and whisker plot from example 4, what percent of gas stations had 55 or fewer price changes? So we got to look at this box and whisker plot here and determine what percent of gas stations had 55 or fewer price changes throughout the year.
I was not paying. I was on the phone with my bank, so I wasn't paying attention. I'm sorry.
That's all right. It's all right. Okay. So remember, these are called quartiles. Okay, and quartile. It's called a quartile because 1/4 of the data is in each of these little sections, right? So 25% is here, 25% is here, 25, 25. If you add up all 25%, you have 100% of the data, right? So it's gonna be 75%. Yes, right. So I'm looking at that. I see 55 right there. That's my quartile 3 in this box and whisker plot, which tells me that 25 plus 25 plus 25 is 75%. I know that 75% of gas stations had 55 or fewer price changes throughout the year. So 75% of gas stations had 55 or fewer price changes in that year. Something like that, right? I probably would have just accept 75% too, but I like to write things out as sentences when I can. All right, now I'll talk about example 5 now. Whoa, look at that box and whisker plot. All right. The following box and whisker plot gives the purchase prices of cars of 114 seniors at West High School. Are there any car prices outliers? All right, so let's take a look. How do we know? How do we know if there's an outlier anywhere in this data here? So let's just look at this box plot. It looks like I have, so it's 114 seniors at West High School. The minimum is right here. The minimum is $3,000. So the cheapest car that a senior at West High School had was $3,000. The median car value of the 414 seniors at West High School was $7,000. That was the middle number. And then over here, there's somebody who had a car that was worth $43,000. All right, they're a high school senior with a $43,000 car. Wow. My car is a little bit less than I think this median right here. Oh, geez. Quartiles are shown on the box plot so that you can find the interquartile range, right? The interquartile range it's going to be Q3 minus Q1. So if I wanted to know the interquartile range, I see that Q3 is lined up right here at 9,100. Quartile 1 is here at 5,200. So to find the interquartile range, the difference between these two numbers, I take the 9,100 and subtract the 5,200 right here, right? 9,100 minus 5,200 gives me the IQR, the interquartile range. The range between those two numbers is $3,900. The boundary for lower quartiles is quartile 1 minus 1.5 of the IQR. So it's like 150% of the IQR. If you're beyond 150% of the IQR, then you're an outlier. So the IQR is 3,900. We're going to multiply that by 1.5. We're going to take 5,200, subtract 1.5 minus 3,900, and we find that if we had a car that had a value of negative $650, that would be an outlier. Of course, no car is going to have a value of negative $650. As poor as some cars might be, they at least have scrap value. So there's going to be no lower outliers here. Right? So no lower outliers because no car was less than negative $650. Let's then find the boundary for the upper outliers, right? We would take the Q3. Q3 is the 9,100. We're going to take the IQR, which was 3,900, multiply it by 1.5 to find out what 150% beyond 150% beyond the IQR would be, and then we'll take the two numbers and we'll add them. Right? 9,100 plus 1.5 times the IQR gives us 14,950. That tells us that any car value over 14,950 would constitute an outlier, right? Any car value over 14,950 would be an outlier. So there is at least one, and we don't know, there could be other cars that are more than that, but there's at least one, our maximum which would be an upper outlier in this case. We would say that this $43,000 is an upper outlier because it's, beyond 1.5 of the IQR, beyond what's going on here, right? So if I took this distance here, like that would be 1 IQR away. And then if I went 50% more, it'd be right somewhere around here. Anything beyond this point here would be beyond 1.5 IQRs away from the quartile 3, which would mark anything beyond that would be an upper outlier. All right, so from this box plot, we can't tell if there are any others because the box plot doesn't give us the original data, right? There could be other cars in here. There could be somebody with a $23,000 car, but we would never know because the box plot doesn't give us that kind of information. Box plots are drawn to scale. There should be on a number line. So the long whisker on the right means that there could be more than one outlier. If we wanted to show the outliers on a box plot, we can create what's called a modified box plot. All right, a modified box plot shows all the numbers that are outliers as a single points past the whiskers. In the following modified box plot, $43,000 is the only outlier, and the greatest price is less than 43,000 is 12,500. So what they did here was they took 1.5 times the IQR past quartile 3, and they said that anything past that is going to be an outlier. So they started putting little dots where there are outliers. So if you were looking at a modified box plot, it might have a dot here, and those dots represent any outliers in the data. So with just what we have right now, we'd only be able to say, okay, $43,000 is one outlier, and it looks like there was 3 other cars that actually represented some outliers, right? There was in this modified box plot here, we have one car showing up that's $16,000. That's an outlier. 21,000 is an outlier, and of course 43,000 is still that maximum. Okay, so let's check to see if you understand what's going on. Examine this modified box plot. Is 400 an outlier? Tell me if 400 is an outlier. What do we think? Is 400 an outlier? So I'll just review a little bit for a second. When we're looking at a modified box plot, right, the outliers are represented as dots, right? The outliers are represented as dots. So to find out if this is a modified box plot, it says it is, to know if 400 is an outlier, we'd have to say, is 400 represented as a dot on this modified box plot? Is 400 represented as a dot? I'm checking that chat out. No one's hitting me up in the chat. No one's coming on mic. I hope I have live learners on the other side of these screens. All right, well, yeah, 400 is an outlier, right? 400 is an outlier because it is represented as a dot. All right, 400 is an outlier because it's represented as a dot. How did I know that? Pardon me. Well, I know that because 510 here is the end of this this whisker, right? 510. So anything less than 510 is going to represent an outlier. All right. So this is a very ugly truck. This is the Chevy HHR retro truck. They stopped making these. I think that's better. That's good. That's good for the world. But anyway, Brian looked up prices of 13 used Chevrolet HHR retro trucks in the classified ads and found these prices, right? Find the mean rounded to the nearest dollar. All right, find the mean rounded to the nearest dollar. I think you should be able to do that at this point. Then I'm going to ask you to find the median, find the mode, find the range. All right, remember that range is the maximum minus the minimum. It's the biggest number minus the smallest number. My advice to you on these would be to break open that calculator, turn that on, go to press that stat button, edit the list. And if you've got numbers like I do, you clear them out. So I'm pressing up, highlighting list one, pressing clear, pressing enter, getting rid of those numbers that I had in my calculator. And once it's blank, I can start to add in these numbers here. Like so, 8,500, 8,500, another one, there we go. Okay, I do 8,500 again. I would continue doing this. I'm not going to finish it. Yeah, this is the easy way of doing this, right? I would continue putting all these numbers in here. And once I had solved, I've got the red button of death on my calculator. This means the calculator is dead and will do nothing. Oh my gosh, look at that. I can press clear, I can press quit, and nothing happens. I can't turn it off, I can't turn it on. All right, my calculator died. Someone tooted farewell. My advice to find these, the mean, the median and stuff would be to use your calculator. Remember to go into 1var stats. You'd press that calculate button again. I suppose I need to turn this on and show you. All right, calculator's back. All right, so I need to put at least one number in this list. I'm going to put let me put in 8,500 just once. All right, once I have one, at least once you have all the data in your list, you can go to stat. You want to go to the calc menu. Go to calc, 1var stats, press enter a few times, and then this X with a bar over it, it's literally called X bar, is the mean. Now the mean of this data set is not going to be 8,500. I'm just giving you this as an example. The median is right here. MED is going to be your median. Your quartiles 1 and 3 are going to be located here, right? And then there's your max, there's your min. So to find the range, for instance, you'll just actually have to take the max, subtract the minimum to find that range. You can find all the 4 quartiles. Remember, Q1 is the first quartile, median is the second quartile, Q3 is the third quartile, obviously, and then max is actually the 4th quartile. Sometimes students forget that the maximum is the 4th, Q4. Technically speaking, the interquartile range, that should be pretty easy. You'll take Q3 minus Q1. We went over that today. You'll look for outliers in the data. You could probably just spot the outlier in this data. All right, so I'm going to have you work on that. And then, well, let's see, I have some questions with Nayeli here. Let's see, she's selling a used Honda. She found some car prices. You're going to find the mean price of the 5 prices listed. You're then going to find how many of these are priced below the mean, right? Once you find the mean, you'll tell me how many cars are priced below that number. You'll find the median price. I recommend using the calculator again, but this list is so short, the median wouldn't be hard to find. How many of these cars are priced below the median? And then you're done. All right. So that's what we're doing for the rest of today, is getting this done. Let's see, we have about 20 minutes left. I'm open to questions. If you're stuck on one, I'm going to stop the recording here.